Today we will talk about Apache Hudi and Spark integration. So what is Apache Hudi? Apache Hudi is an open standard table format for analytical dataset. It is very similar to Iceberg and Delta Lake open standard table formats. It is used to manage metadata, schema, and the transaction of a table. As you can see in this diagram, we have four layers: compute engine, table format, file format, and file storage. The middle two layers, table format and the file format, managed by Apache Hudi. It will decoupled compute engine and the file storage. If we map or if we represent each and every layer with some sort of tech stack, then we can represent like this way. Compute engine we can represent with Apache Spark, Trino, Flink, and Athena, which are used to process data. Table format and file format come under Apache Hudi. So table management and table format managed by Apache Hudi, and the file format managed through Parquet files. And file storage could be anything. It could be S3, GCP, Azure, and the local you can use. So we can easily decouple our compute engine and the storage engine with the help of open standard table format, and that we have Apache Hudi. So what are the main use of Apache Hudi? The first one is schema evolution. With the help of schema evolution, you can create, update, delete the table. You can perform all the CRUD operation. Second one is a time travel. You can go back in time and you can see your old data. So it's like you are checking your old snapshot or past snapshot of your data, like 1 hour, 1 day time window. You can go back. It has a support of asset transactions and concurrency partitioning. With the help of Apache Hudi, you can partition your data with the given or specified column. So you can scale up your data easily or shard your data. CDC is a very unique feature which is not available in Iceberg and Delta Lake. CDC is change data capture. With the help of that, we can capture the incremental changes. It's not like time travel, because time travel has a particular state of a data, a particular snapshot of a data, but CDC is capturing all the changes, insert, delete, update, these kind of insertion or all the correct statements it will capture. So it's very useful when we are planning to migrate data from one system to another system or replicate a data. Now, how to create a Apache Hudi table in Spark? So we can define a SQL query like this way: a create table statement, which is very similar to standard SQL. The only difference is we will need to specify using Hudi clause and partition by. Using Hudi clause will tell to the system create a Hudi table, and it should partition by department ID. Now table type. Apache Hudi has a two type of table that you will need to define when you're going to create it. Cow is a default table type. If you not specify, more is table type which you will need to specify explicitly. So merge on read and copy on write. We will cover the difference of these two. Now, if you want to define a table type while creating a schema, then this is the way. Using table property, use type clause where you can specify cow or more. Cow is a default table type if you're not specifying while creating schema. Remaining using clause and partition by clause will be same. Now when to use cow and more. Cow basically used for heavy read traffic for analytical or reporting purpose where we have a read traffic more, and more type table we'll use for write heavy queries or where we have a real time or frequent updates, heavy write workload. So for write latency wise, cow has a higher and more has lower. Read latency, cow has lower and more has higher. Update cost, cow has higher and more has lower. Operational complexity, cow has a less operational complexity and more has slightly higher. So operational complexity meaning the internal file structure. When we define the table type, the schema management and the file management is slightly different in cow and more. Number of files are higher to manage the more type of table. So it will consume more storage on your system if you create table with more type. Now we can jump on demo part. I have already installed Spark on my local machine. We have to launch PySpark terminal first with the help of this command. So my terminal is running. You can see I have fired this PySpark command here. Now first we will start with cow table. You will import couple of basic things like PySpark SQL and and datetime. This is the schema we have. It's an employee table. It has employee ID, department, salary, sales amount, performance score, and last updated time. And here we have uh, hudi options. In hudi option, we have to define table name, table type, cow, copy and write, primary key ID, employee ID, partition ID, which is department ID, pre combine field. In case of conflict, this column is very important, last updated, and operation type is upset, which is valid for all the insert, deletion, all the CRUD operation. And we'll define the path of our table, which is slash temp slash hudi underscore employees underscore cow. These are a couple of entries I have, 3 entries. And now first we will create this using Spark data frame create function. We will pass initial data and deploy schema. Okay, data has created. We can read it using this. So you can see uh, the data and how data is organized using Apache Hudi. And if you go to backend and see the structure, you can see this under temp, this table has created this folder hudi underscore employees underscore cow, and it has two Parquet file under 101 and 102. So 101 is a, if you remember, this is the department ID. So we have partition table department ID base. So there is a data segregated based on department ID. This column department ID we have. And if you want to see data with the where clause, we can also write this way and see where department ID is equal to 101. We have two rows. And if you want to add a new column where department ID is different, 03, we can use this one. Here we are inserting new record, but department ID will be different. Okay, so we can read the same thing here. Now you can see another record here, fourth record, and let's see the structures. See, initially earlier we have two partition ID, two folder. Now we have another third one, a third Parquet file. So data partition is automatically managed by Apache Hudi inside Parquet files. We can perform more operation like update, delete, and we can delete whole table also. Now we can quickly jump onto the second exercise, which is more type of table. So it's a kind of a same thing, only the difference is the hudi options. Hudi option will be different in this case. So let me create another table here, clear this. Again, similar type of table we will create. hudi options will be different. The change is merge on read. This option is very important in this case. These are the hudi options, and the base path will be like temp directory will be same, but this root folder will be different. It will be hudi underscore employees underscore more. Earlier we have underscore cow. So this is the data. You will get this data and the schema here. And here you can see we have again three employee ID, department ID 01, 02, and 03. So data is created. Now first we will see the directory structure here. So you can see the table is created. The more table is created. If we go inside, this is the folder. We go inside. Now here we have three partitions and three files we have. Let me read it. Read command. So we can read. We can add a more record in this. Try that also. Just adding one record. Okay, we have added one more record, and let's see is there any difference. Yes, so there is a new Parquet file created under 013 folders. You can perform more operations like update, delete, or you can completely delete your table. If you want to delete your table, I think we can try this one also, just to delete all the tables and everything. Yeah, this will going to delete your table. Run the tree command. Now it's empty. The files are deleted now. Yeah, that's all for now.